Okay, in this video we're going to talk about how to combine our eigenfunctions. So this is a continuation of the same example from the last couple of videos. We were able to separate our partial differential equation into two ordinary differential equations. We were able to find eigenvalues and eigenfunctions. This is actually a product of a function of t times a function of x. Just be really careful. It's really easy to put an x or a t in the wrong spot. Make sure you're keeping track of which one's supposed to be which. Something that I forgot to mention in the last video that's about to be really important is that when we actually found these eigenvalues, these were in the case where lambda was positive, and so that means that our n's have to be numbers greater than 0. Okay, so just food for thought. Okay, looking back at the differential equation that we started with, we still haven't used this. And we still have a group of constants that we haven't solved for. And those two are going to be related. We're going to use this to try and solve for this. So we have multiple eigenfunctions, and we're supposed to have u of x 0 equals f of x. And so you could ask yourself which one of these eigenfunctions satisfies this initial condition or boundary condition. Probably none of them. So instead, we're not going to have a single eigenfunction that's going to be a solution. We're going to have to combine multiple eigenfunctions to get a solution. It turns out if un is a solution, the sum of the un's should also be a solution. So our general solution, u of xt, is going to be a sum from n equals 1 to infinity of un of xt, which means that it's a sum from n equals 1 to infinity of an e to the minus n squared pi squared kt over l squared sine n pi x over l. Okay, so adding up all the un's should give us the big whole shebang, all the solutions. Now I'm ready to plug this in and try and solve for my unknown constants. So plugging in 0 for t, we're supposed to get f of x. Plugging in 0 for t is going to go right here. So sum n equals 1 to infinity, a sub n e to the 0 sine n pi x over l. So again, really important that you keep straight which one's t and which one's x. E to the 0 is 1, so I can just not even bother to write that. Okay, and then I have to figure out what these constants are. But we lucked out that we have constants times either sine or cosine. In this case, it was sine. Depending on your initial conditions, like if this had been x prime of 0 and x prime of l, we might end up with cosines at this point. So it's not always going to be sines, but in this case it is. And actually this looks familiar. F of x equals infinite sum of sines. That looks like a Fourier sine series. And so this capital AN is really our BN from the sine series formula, which is defined to be 2 over p integral from 0 to p f of x sine of n pi x over p. Okay. Also comparing this series to the format of the Fourier sine series, it was supposed to be Bn sine n pi x over p, and so I guess that tells me that L is equal to p in this case. And so that means that our formula for a sub n is going to be 2 over L integral from 0 to L f of x times sine of n pi x over L dx. Okay, so I don't actually know an f of x. I wasn't given it in the problem. It was left as a generic function, and so I'm going to have to leave my answer like that. if the initial problem had told me a particular function, then I would be able to stick it in there and integrate and actually solve for the constants a sub n. Some of your homework problems are going to look like that. I'm trying to solve like a more generic version here. So I'm not actually going to do the integral, but we would do the integral next. So if this is our formula for the a sub n's, then all I need to do is recopy our formula for the answer, which was right here. So my final answer, u of xt, is equal to this, where the a sub n's are given by this formula. Again, if you knew a particular function f of x, you would actually integrate, find out what a sub n is. It should be a formula that depends on n, and then you'd stick it in right there, and that would be your answer. It's an infinite series, it's messy, but it's an answer.